Welcome back for part 2 of the project for Math 106. I feel like the second half tends to feel a little bit easier, but that's because we don't have to do as much of the calculation ourselves. So if we take off where we left from, we finished part 3, we made a model by hand. We talked about the x-intercepts, the y-intercepts. You're going to go through and answer all the questions, of course. And then for part 3, we get to do a quadratic regression straight in Desmos. So a couple of things I want to point out in this formula. You have to, the first time I did it, I left off the 1 for y. So lots of little things you have to watch out for. y1, and then you need to use the little tilde. And now when I type this, I'm just going to type it below just so you can see. I didn't even have to do anything special. I just typed the 1 and it's like it knew where to go. I typed a x1 again, it goes down, and then I did use the caret to get the squared. Plus b x1, again it puts it right down for me, and then plus c, and of course the answer is going to come out the same. Just to make sure you know how to read this, these are your values for a, b, and c. So when I go and plug this in, it will be y equals this number, x squared, plus bx plus c. And notice your c again is really close to the original intercept that we were given in our chart. Really close to 5542. Not exactly, but still pretty close. So I went ahead and graphed it and I talked about it. I wrote the equation. I talked about what the x-intercept means. I talked about what the y-intercept means. Now for this, I'm not going to lie, I cheated. I totally zoomed out and was like, oh look, there's the or the x-intercept, sorry. This is the y-intercept, and I found my x-intercept. I only talked about the one on the right. You can talk about both. They're definitely very different from the one I calculated. It definitely has a more likelihood of being accurate, but still not very likely that in 66 years from 1997 that it's going to be 0. So I talked about all of those intercepts. I also found the vertex. I just used the formula x equals negative b divided by 2a to find the value of the vertex, which I showed here. But you could also go in here and just click on it. Desmos is amazing. It will show you everything you need. So it's saying that in 20 years from 1997 that the number of FM stations is going to go down. Unlikely, but could happen. I did actually go and Google because I thought it would be fascinating what the value is right now. I'm trying to find where I put it. Put it in here somewhere. Okay, I'm pretty sure I found it. Right now is about 6,600 stations. So if we took a second and said this is 2024 minus 1997, so this is 27 years, and put 6,600, I could actually, and I did graph it in my thing, but here it is. Look how close that is. I was actually surprised. So even though I'm not convinced that this is an accurate model, according to the data right now, it's looking pretty good. It's definitely way far off from the one I calculated, so that's much less accurate. So that's part 4. We're going to go through and do the quadratic regression and talk about all of it and how well it fits the data. Then we're going to do some test values. We're going to see which one of these we think is actually correct. Now, often I would do test values in between the points, but we didn't skip any numbers. So I'm going to do one on the end. So if you have ones that have skips in the middle, you can do them in the middle. But the idea is to see which one's closest to your model. So I'm going to do -1 and 7, since I go from 0 to 6. I plug in my x's, -1 and -1, and then you can look at the graph. For this one, these ones are really close. If you go look at the values for x equals -1, these values are really close. So both of them are going to be quite close. But if you go to x equals 7, however, this is where they definitely diverge, and where I believe that the quadratic regression model is more accurate. I don't think that the number of FM stations is going to go down, especially seeing where this data point is in the future. So I plug them, and what I'm doing is I'm comparing the two models. That's what I wanted to point out, is that by plugging in test values, we're comparing the two models. So for x equals -1, it's not, those numbers are really close together. But for x equals 7, they are over 500 apart. And that's a pretty significant difference. So in that case, I would say that I feel like the red or the quadratic regression is more accurate than my model. So that's what we're doing, is we're comparing the two models. And then That's what you're going to do at the test points. And then finally, you're just looking at a conclusion. This just gives you things to talk about. Is this a good model? Is this not a good model? For me, I would still be interested in doing a linear model and comparing. But even though I didn't think it was going to be a great model, this current data point I find actually fascinating because it looks like it's not so bad. But talk about the value of a model. But then it says, what cautions would you give? No model is going to be perfect unless something is perfectly linear, which very few things in life are perfectly linear or perfectly quadratic. Then it's going to be an approximation. And I think that's the important thing to know about regression is that it's an approximation. It's close. It's going to give us a good estimate. And sometimes that's all we need is a good estimate. And so that's the value. But if you're looking for an exact value, then a regression is probably not what you're looking for. But this just gives you a way to conclude. So I think that kind of goes through the second half. So you have your introduction, you go through your table, you scatter plot it, you're looking at it, then you calculate your own model. I think that's probably going to be the hardest part. Then you do your quadratic regression in Desmos. The hardest part here is going to be discussing it, finding the x-intercept, y-intercept. Again, you can zoom out. You can find it. Desmos will do it for you. You're welcome to do it by hand, but Desmos will do it for you. So take advantage of that. And then then do a couple test values, plug in the values. Again, you can use Desmos to help you with that. I will admit that I went on here and I clicked it and found the values. Or you can use your calculator. Either way works. And then see which of those answers is most accurate to tell you which model you think is more accurate. And then conclude. And you've got this. If you have any questions, let me know. And hopefully you learned something by going through this project and learn a little bit more about regression and quadratic functions and how they can be useful.